Wilson. I work for Sun Microsystems with the Filebench team, which is a part of the Solaris organization. And a couple of my colleagues are also in that team, Eric Stars and Spencer Shepard, and there's been contributions by previous other Sun employees in the past. Try to do this more carefully. So motivation for Filebench. This started several years ago in the performance group at Sun because they were concerned, trying to look at performance of file systems because they were concerned that the benchmarks they had available at the time were either generated fairly simplistic workloads or they were fairly complicated and expensive to run. They wanted something that was sort of a middle ground, and the Filebench was developed to be that particular middle ground. While it's we believe it's fairly easy to use, it also allows you to emulate quite a few different applications and the workloads that they would generate. The Filebench architecture that achieves this, we have workload files, which actually encapsulate the behavior of the particular application that we're trying to emulate. We have the Filebench framework, which executes these essentially as instructions and produces the actual I/O. We also have capability for back-end plugins to work with different types of file systems, though presently the only plugin that's there is the POSIX one, which talks to a local file system. I'll have a little more to say about that later on in the talk. Some of the features of Filebench. It has the ability to emulate a wide variety of workloads, as I mentioned. It has built-in support for large, randomly generated sets of files, which we call file sets, in a multi-level directory tree, and of course the ability to access those by various methods. The actual work is done by what we call flows, which are encapsulated in threads and processes, so you can have lots of threads, lots of processes. They can be multiple instances of the same thread, different threads, and they all will then produce the work against the files in the file set. And their behavior can be customized through attributes which are passed to them. So here's an example of a very simple random I/O workload. Notice at the top we also have variables which you can set to default values within the program itself, the workload file, but you can also change them on the fly using from the command console. And there you see a simple one with a single file and a process and a thread, multiple threads, one thread. And this one is doing a simple operation on the file, a random read. So one of the things is that we've recently put Filebench within the Open Solaris, and in order to do that, there will be quite a bit of cleanup of the code and some bug fixing. It's now available both through SourceForge and through the Open Solaris site and through these Solaris Developers Express Edition that Sun passes out. We've added versioning so you can keep track of what you're doing and made some other changes to make it easier to use. We also are adding some new features to it, a thing called random variables, which each time you access the variable, you get a different value from a random distribution that you defined, and composite flow-ops, which are super flow-ops, made out of smaller flow-ops, essentially adding subroutine capability to Filebench. Both of those are actually have working prototypes and will be putting back soon. We have people working on NFS plugins, and we hope to eventually have a SIS plugin. And finally, we have investigating multi-client frameworks in order to have more than one client feeding your really massive server. Right now, it's Filebench is limited to a single client. And as it says, it's open source, and we encourage people to help us. If you want more information about Filebench, you can see me at the poster session. We've also added a lot of more documentation online on solarisinternals.com. Including detailed information about how Filebench works and more information about the particular file, how the flow-ops work,